The next question says the moment of inertia of a uniform cylinder of length L and radius R about its perpendicular bisector is I. What is the ratio L by R such that the moment of inertia is minimum? Now can I say this is the cylinder of length L and radius R, and the axis which they are talking about is this, the perpendicular bisector of the cylinder. Now since the cylinder is not mentioned as solid or hollow, we are going to assume it as the solid cylinder. Now for the solid cylinder, the moment of inertia for this axis is m L square by 12 plus m R square by 4. So it is like the rod for which this is the axis, so moment of inertia will be this, and for this part of the cylinder we can say this axis is going to pass like a diameter through a disc, for which the moment of inertia is mr square by 4. Now for the inertia to be minimum, we need to say the di, the first order derivative, should be 0. So we take a partial derivative for this and we get di is equal to, we can take m by 4 common, we are left with L square by 3, for which the derivative is going to be 2L dl by 3 plus R square derivative is going to be 2R dr. So basically we are derivating I as di, L square derivative is 2L dl and R square derivative is 2R dr. And we are going to equate this to 0 because I we want to be minimum, for which the first order derivative should be 0. That means if we rearrange this equation, we get 2L by 3 dl is equal to minus 2R dr. Definitely this 2 gets cancelled and we get dl by dr is equal to minus R into 3 by L. So let's consider this as equation number 1. Now we can also say that the volume of the cylinder, which is pi R square L, is going to be constant. So if we take derivative of this, what do we get is pi R square derivative of L as dl plus pi L derivative of R square as 2R dr, and derivative of constant is 0. Now why are we doing this is because we want the answer for L by R. So L by R is present over here, but there is an unknown dl by dr which we need to find. For that we are using this again with the partial derivative to get an expression for dl by dr over here. So I have applied uv rule over here. So u derivative of v plus v derivative of u, where pi being a constant remain as it is. So if we take this on the other side, we get pi r square dl as minus 2 pi r l dr. So definitely pi gets cancelled, one r gets cancelled, and so we get dl by dr as minus 2l by r. Now this we can consider as equation number 2. Now since for equation 1 and 2 the left hand side is same, we can equate the right hand side and we get minus 2l by r is equal to minus 3r by l. So minus gets cancelled. If we cross multiply, we get 2l square as 3r square. So L square by R square as 3 by 2, and so if we take the square root, we get L by R as root 3 by 2, and that would be the final answer.